Hi, I'm Hasika and we're from Group 20. We'll be presenting our experiment on how to develop and implement effective corrosion prevention on our samples, which are batteries, in different environments. So let's go!
In this case study, we evaluate the effective of a corrosion prevention method using an anti-corrosion on battery. For battery, we use two battery we spray in anti-spray corrosion spray, while other two we unspray. For each part, we keep out at outdoor, and other was we keep in outdoor. Operation we make daily for 2 weeks. We look for signs of corrosion such as rust and discoloration. Photo and a video we take to see the result. And our main objective was to evaluate the effective of the protective spray under different environmental conditions.
To begin this experiment, we prepare all the material needed. Spray paint, and battery. We bought the together. We use the 4 battery in total. Two wear paste outdoor to observe the effect of weather, and the other 2 we keep indoor for comparison. Each battery was either coated with red spray paints or left uncoated. We place them in their respective environment and observe them every 2 days. Okay, our goal was to see how fast corrosion happen under different conditions. For the outdoor battery, the uncoated one start to show rust quickly, while the coated one start mostly clean. By the last day, uncoated battery had rust on the tops and metal was clearly damaged. The coated battery still look red. We were only small sign of corrosion at the terminal. Meanwhile, the indoor battery showed almost no change. Ever the uncoated one look neatly the sum from start to finish. This show that corrosion happen much faster outdoor than indoor. And using a protective coating can show the process down.
Hi, my name is Esther Desini, so I'm here to talk about our group discussion part. So first of all, I'm going to talk about the objective of the experiment. So first objective is to assess corrosion problem in the battery. The main material we choose is battery, so we are going to observe the battery. And second, to analyze the effectiveness of protective coating under different environmental conditions. However, the environmental factor study, there are 3 things, which is humidity, temperature, as well as chemical exposure. Then we are going to compare between the outdoor and indoor materials, which is our battery. So the result show that the outdoor battery that uncoated show visible rust and discoloration, and also structural failure. While the coated battery remains almost intact with only minor oxidation at the caps. So now I'm going to talk about the indoor material battery. The indoor battery show remains because there is stable temperature and humidity slow down the corrosion. For the uncoated battery show minor corrosion, while the coated battery remains in great condition. Besides, now I am going to talk about the effectiveness of coating. So the effectiveness of coating is to prevent the moisture and the oxygen from reaching metal surface, and importantly, reduce corrosion especially in outdoor environments, and is able to extend the battery lifespan as well. Then the chemical exclusion also increase the battery corruption, and it is very important to have protective coatings, especially in outdoor, and also for indoor storage is very important to reduce corruption that with coating as well. Shortly, the uncoated battery corrupts quickly in the outdoor, and while for the coated battery lasts longer and perform well. As the environmental management and protective coatings are the key strategy for corruption prevention, and battery can last longer. Thank you. Hi, my name is Esther Sini, so I'm here to talk about our group discussion part. So first of all, I'm going to
This study looked at how environmental factors like humidity, temperature, and chemical affect battery corrosion. Results show that battery placed outdoors without coating had nil rust and damage due to moist and air, while coating batteries stay mostly intact with only slight corrosion. This shows that coating helps protect battery in harsh conditions. Batteries stored indoors with stable temperature and humidity show little or not corrosion on both coating and uncoating samples. In conclusion, outdoor environment increase corrosion risk, coating offer good protection, and indoor storage slow down damage. This finding can help improve battery safety, reliability, and lifespan.